All right, so if we're looking at this question for the MCAT, there are two equations that we should know when dealing with springs. First of all, there's the equation for potential energy. PE is equal to 1/2 kx squared. And then there's the equation of the force that's being exerted by a spring. We fix that F. Force is equal to kx. So x, of course, is the displacement of the spring, how far the spring is. So if this is a spring, how far it's either displaced, like it's either squished or stretched. Okay, and typically we do a negative here, but when I deal with these sorts of things on the MCAT, I just ignore the negatives because it's not really, we can figure out the answer without using negatives. So which equation do we want to use here? Of course, we want to use potential energy. So this is the correct answer. But really quickly, I just wanted to address an interesting idea. Let's say you forgot which equation deals with what. Let's say you forgot about this part. You know 1/2 kx squared, and you know kx, but you don't remember which one goes with which thing. And there are two ways that I would recommend you kind of can remember that. First of all, this equation is a lot like 1/2 mv squared. It's basically analogous to it. 1/2 m in this case versus k. M is it's a certain quality of the object that's unchanging, right? The spring constant of a spring doesn't really change, I guess, unless the spring gets hotter or colder, but for the most part, it doesn't change. And the mass of an object is not going to change. And then x is a quality of the object that we can kind of apply. And so in this case, it's displacement. And then when we're dealing with the other equation, it's v, of course, v squared, right? So the velocity of the object. And so you could think of it that way, that it's analogous, right? That calculating energy, you do 1/2 something something squared, right? But there's another way that you can do this, which is that if you look at this, the variables that we've got here, the force constant is 200. And specifically in terms of units, it's newtons per meter, right? And then when you multiply that by the displacement, which is 0.2 meters, and let me just use units, you end up with newtons. And of course, newtons are a unit of force, but they're not a unit of energy, right? And so this equation is the equation for force, right? When we do this, we end up with force. So from that, we know that this is a force equation. And then we, of course, know, therefore, that this is the potential energy equation, right? All right, let's go ahead and solve it. Potential energy is 1/2 kx squared. So 1/2 k is 200, and then x is 0.2 squared, right? And so let me do this. 1/2 times 200, that's 100 times, and then what's 0.2 squared? That's going to be 0.04. 0.04, right? And so 100 times 0.04, so 100 means we move the decimal points, or the decimal 2 places to the right, right? So the number, of course, is going to get bigger, so we move the decimal this way, 1, 2, right? 100 has 2 zeros, so we move the decimal 2 places to the right, and we end up with 4, right? So the correct answer here is going to be 4. So it is A, 4 joules. And of course, joules are the units of energy, of potential energy, right? So the correct answer here is going to be A. By the way, joules, I should just point out, we know here that we got the right answer also because, so x squared, let's go ahead and look at the units. So 1/2 kx squared, k is meters, right? So k is Newton meters, and then x squared is going to be meters, so squared, right? So these are going to cancel partly, and we're going to end up with newtons times meters, right? So we end up with newtons times meters. And it turns out Newton meters, or Newton times meter, is the unit of energy, also the unit of work. They have the same units, right? So from that, we just, we know that we got the right answer, right? And of course, you'd have to know that joules are actually newtons times meters, which you would know from the equation work equals force times distance, right? Newtons times meters. And again, the units for work and energy are the same. But that's kind of beyond the scope of what you need to know. I just think sometimes knowing these sorts of things can help you kind of like figure out the equations you need to know if you don't really remember, the equations themselves. So anyway, the correct answer here is going to be A.